Right. Good morning, everyone. I hope it's morning over there. It's evening here. Welcome to the position paper session 1 for the first ever multisensory augmented reality workshop 2021 under Interact 2021. I'm Thilina, Halloluwa, and I'll be chairing this session, which will run for an hour. There'll be 3 talks, and every speaker will be given a 15 minutes for their presentation, followed by 5 minutes question and answers. So our first talk today is titled Towards a Generalized Architecture for Multisensory Augmented Reality by Dariana Thomas and Lars Erik Holmquist from School of Design, Northumbria University, UK. Floor is yours.
Hello, can you hear me?
Yes.
And you can see my picture?
Yep.
Okay. Good morning or evening or whatever it happens to be in your time zone, everybody. I am Lars Erik Holmquist, and I wrote this position paper together with Dariana Thomas, who is a PhD student, and we're both at Northumbria University in the UK. And we really wished to have been in Italy for the Interact conference, but we're stuck here in Britain, in Newcastle at the moment. So I hope some are enjoying a better weather than we are, at least. So this talk is really more of a, I would say, halfway between a proposal and a thought experiment. If you look at, and it follows very well on the keynote, by the way. So I was very happy to see the issues raised on different modalities in the keynote, because it dovetails very nicely with what we're talking about. And by the way, Dariana is with us on a very shaky internet connection, so we'll see if she can chip in, but her internet keeps going in and out, so that's why it's me giving the presentation at this time. So as we know, and this is more of a recap than anything else, traditional augmented reality is very focused on the visual senses, either through headsets or handheld devices or projections. And this is how it's been for as long as the field has existed, really. But there are some issues. Certainly, visual is a dominating modality for humans. But many people have impaired or limited visual senses. There's also the risk that the visuals dominate over other senses, and that there is that they actually interfere with the other visual information that we are taking in. For instance, if you're in a driving situation, you don't want your visual senses to be overloaded because they're necessary for the task you're already doing. So we think that multiple modalities can be really beneficial for some tasks. And there's been a bit of work in this in the HCI community. For instance, putting information in the periphery using different senses, like physical installations, like the famous dangling string at Xerox PARC, or ambient media at the MIT Media Lab, and so on. So there's been some attempts to offload the visual and move information into other senses. What's happening now is that, as we saw in the keynote, there is a lot of opportunities for creating new forms of output, whether it's things based on haptics or taste, smell, sound, and so on. We could engage many more of our senses. And I thought a good example and a good commercial example of that is 4DX cinema, where you sit in a chair watching a movie, but you're also being assaulted by different kinds of stimulation. The chair moves, there's wind blowing, somebody pushing your back, there is smoke coming out, flashes. So that's an example of how we can engage many more of the senses than just the pure visual. But if we looked at the previous work in this, and we found some applications that are using other senses to communicate information. But what's striking is that they're all bespoke. There's one application is doing this with one set of data, another is doing that with another set of data using different modalities, but there doesn't seem to be a lot of generalizability. So what we're suggesting is that rather than sort of starting from scratch each time, we should have a more scalable approach to multisensory augmented reality. And the inspiration really comes from graphics, where this is already standard. You don't anymore have an exact number of pixels that match the exact resolution of your screen. You typically store information in an independent resolution format like vector graphics, and then you scale it to whatever the capability of your display output is. So this is sort of the similar idea. So what we're doing is that we're basically breaking down the problem in three components. The first one is the data. So what is it that we actually want to display? What is the underlying information? The second is the modality. How do we want to display it? And then what we really need, and this is where the trick is a transformation function between number one and number two. So a more obvious way of seeing it is this diagram. And actually now as I see it, I could of course go the other way as well, that you could have input, transformation, and data as well. But this is the first proposal. So you have a set of data, you transform it, and you output it in some way that fits the situation. And the main advantage of this is really that we decouple the information from the display, just like resolution independent graphics. Doesn't matter what the data is if we can have this transformation function. And it could also allow a user to choose the best modality for their particular situation and their capabilities. So for instance, the senses that fit best in a particular situation, or the senses that they are most likely to use, or if one sense is impaired, you could transfer the modality to another sense. And the other thing is that this makes it easier to develop new systems. So rather than build the whole system bespoke each time, if you need to add a new modality, you would, at least in theory, be able to add that as a new module to your system, rather than building the whole system from scratch again. So to make this more concrete, let's look at a couple of examples. So wayfinding is a very common task. We've all used Google Maps or Apple Maps or something similar to find our way from A to B. The augmented reality version of this is at the moment something like Google Maps AR, which shows you a visual indication of where to go. I'm showing it here on a phone, but obviously it could be on a head-mounted display as well. But the visual data is not always the best. It could be distracting. Like I said, if you're driving, you don't want something popping up and obstructing your view. If you are vision impaired, you may still even more need wayfinding, but vision is not your preferred option. There are things that make displays difficult to read, like different light conditions. And like I said, it can literally get into the way of what you're seeing. So if we break down the problem, the data in this case is a route from A to B. And that can be set by, for instance, your GPS location, the target location, and the route between that. The output can be any number of outputs: visual, haptics, audio, and so on. And then we needed transformation functions that takes your location, where you are on the route, and gives a cue to where you actually want to go. So I'll just give two examples of that. So this is the active belt. It was presented at UBCOM 2004. It uses a GPS to get the location. It uses a vibrating a vibrator that is spread around your body in a belt to give you a particular cue. So if you're supposed to go left, it vibrates on the left. If you're going the wrong way, it would vibrate in your back and so on. So that's one example. Here's another using sonification. So this system is actually for blind users. It uses auditory cues presented at UBCOM 2013 to give you a 3D sonic indication of where to go in the environment. So what we have in the more general case is that the data is a map, a start point, and a journey mapped out, a transformation function that uses your position on the map to find the correct instruction and translate that into the appropriate sensory output. And then, as I showed, we have a number of different potentials. And I was actually quite inspired by Professor Ranasinghe's keynote to think about other ways of doing navigation. So could we have taste-based navigation? Could you get like a sour taste if you're going the wrong way? Could we have smell-based output, directional or otherwise? Could we have heat-based output? Could you have wind? Could there be, like in the 4DX cinema, water splashing on your face? So the opportunities are really endless. But the whole point is that data in this case is the same. What is needed is a transformation to the modality that is most suitable for the situation. Another example that we are working on now is, and this is where Dariana's been working most recently, is working from home. So we wanted to find out what is the role of augmented reality in the home, and what modalities and interactions are most suitable if in that situation. So we've done a number of focus groups to find the objects that people commonly interact with when they are working from home, and discussed how to augment these objects and the interactions with these. Participants, they also suggested many different modalities. Again, visual was one of them, but they were interested in haptic feedback, the temperature, gestural interaction, audio, and visual. So the current work is using the architecture that we proposed. We could connect different objects through a single device and give the users in the home the output that they need adapted to a particular setting or particular object. And things that are interesting in this case is things like reminders, taking a break, and motivational things, and also things like incoming information, email, and so on. So if Dariana can get her internet up and working again, we do have some examples of this that we hope to show in the demo session. Where we are right now is like I said, it's more of a proposal and a thought experiment, because we're working on the actual demonstrations, but we're using this architecture as a kind of way of thinking about how to expand this into the future. And we do think that it's important for users to be able to choose the modalities rather than being stuck with a particular one. And we want to do some testing of these so that, for instance, mix and match between different data sources and different modalities to see both if the idea scales and also what kind of use cases are most interesting. So just to recap, this is kind of the basic idea of the whole position papers. You take data, you transform it into a particular output, and the decoupling is the main point. The advantage is, well, there's two things. One is the choice, that we actually have the opportunity to give you not just one size fit all, but adapt to the user's need and the user situations, and the other is that it would potentially make the construction of systems easier and more flexible, because you rather than having a bespoke system every time, when you add a new output modality, you add a new transformation function, but you don't actually change anything else in your application. So that's it from me. Thank you very much. So I think we have about 5 minutes for questions.
Yes, thank you for the excellent sort of the presentation. Now the floor is for the audience to ask questions. We have five minutes. Sam, yes, Sam.
Hi, I was wondering when you present this like generalizability between the sensory modalities, does it take into account the differences between sensory perceptions between senses? And if so, like could you speak at all specifically on how you aim on perhaps translating an experience of one sense into the other, if that's the intended application? Is it through looking at how, I don't know, for example, how that might arise naturally in certain different cognitive styles like synesthesia, where you have a mapping between color and sound, or color and certain textual properties?
No, I don't think we're talking synesthesia here. So the idea is not that synesthesia is when you, for instance, see a color and it appears, or you're strongly associated with a sound, for instance. That's not actually what we're thinking about. I think we're more on a kind of a basic level. How can we get the right output for the right situation? So for instance, if you are, and the wayfinding example is by intention pretty simplistic, because there it's like a directional. How you would translate that to, say, a taste-based interface, I honestly don't know, and that may not be the best situation. So I think, for instance, I was being a bit speculative there when I said you can do all these different kinds of interfaces. I don't think that's really where we would be going. You would in many cases find that actually this doesn't fit. There are modalities where this information just doesn't fit, and then that's the way it is. And I think also, to be honest, one reason that visual is so dominating is that it's so expressive. The expressiveness of visual is very, very high, whereas the expressiveness of haptics, for instance, is actually much lower. The amount of bits that you can communicate with visual and audio is extremely high. So and that's something that goes all the way back to ambient media as well, that you would see that the actual number of bits you could get through is quite low, but it may really be a game changer in some situations where you really need a certain modality.
Yeah, I suppose so, and the ability for haptics to actually contain, despite its I guess what I took from your saying there was that vision is able to hold more information, but maybe there are cases in which haptics are able to hold higher representational experiences such as emotion. And there's some really interesting work in ultra haptic sensations where certain touch patterns on ultrasonic feedback surfaces are able to generate quite intense experiences. And so I suppose, yeah, it really does depend on the application.
And that is another interesting thing to think about. What is the correspondence between a particular type of information and a particular modality. So for instance, if you're talking about spatial information, that may actually be well communicated with haptics, whereas other types of information may not be so well communicated with haptics, for instance.
Thank you.
Yes, Thomas, you can go ahead.
Yes, thank you, Lars-Erik, for an interesting idea. So I think the way it's a relatively abstract idea, and the way I think about it, I'm also basically from the Ubicomp community, and what happened there 10, 15 years ago is that we started to talk a lot about middlewares to, instead of building all these new systems that use very specific sensors and actuators, we've got tired of that, and people started to build middlewares so that it was much easier to swap in and out the sensors and the actuators. And what you, the way I interpret what you're saying, you and Adriana, is that you want to create a more mature middleware situation where so it would become easier to attach and detach sensors and actuators, and then also to add a user interface somewhere there. That's how I interpret it. I don't know if that makes sense.
I think middleware is one way of describing it. Although middleware has other connotations. Middleware is more like, to me, seems more like one generalized. One architecture to rule them all. I still don't think that's where we're going. But if you look at even something as simple as a phone, of course there is middleware basically connecting everything together. So, but that's more of an operating system, and there's also been a standardization of that has basically now in the 14 years since the iPhone was introduced, we basically arrived at a completely set.
In fact, this is exactly what I was thinking about, that perhaps we could have some kind of standardization, some kind of letting the operating systems be a bit more flexible with regards to the sensors and the actuators.
And I think that so the middleware would be doing a lot more, but what we're talking about is really the transformation. How do you transform particular data set or instruction into a particular modality? Whereas while I thought middleware is maybe not the right word, is because the middleware does so much more in most cases.
Right. Thank you.
I think Nimesh had a question, or?
Yeah, I think I want to add. First of all, thank you so much, Lars, for the very interesting presentation, as well as I think this work is very, very important at the moment, the generalization frameworks, and at the same time, it's very, very hard to achieve as well, I guess. I think that's one of the reasons we were looking at like different individual context and usage scenarios, and then try to create general frameworks for these particular aspects. The reason I want to interrupt highlight some aspects from your conversation with Sam is that you mentioned like some of these the taste-based navigation example, for example, it doesn't make sense, right? But it's also depending on the different users and the context of use as well, right? For example, we have seen like a lot of people using the mouth or the tongue-based interactions for the wheelchair navigations, or like the speech conversations for the paralyzed people, for example, as well as like when you think about the other communities like visual impaired or sensory impaired people, for example, people with hearing loss and other kind of sensory loss. So probably there are sort of like the user populations we can still generalize some of these wacky ideas which might not work with or which might not important as much as in other cases or in normal situations. So that's kind of like the good thing or the beautiful thing about this multisensory work, as well as the challenging thing, right? So it's very hard to generalize in like a more general framework, but it's even in a more general situation, something will not work, but in a more specific setting or a niche scenario, it might very, very important. So again, I don't know, I don't have a question or anything, but I just want to explain my opinion and viewpoint on that conversation.
Thank you.
Thanks for the great work and the initiatives.
Yeah, I think accessibility was actually kind of one of the background motivating factors for this.
Exactly. Yeah.
So I just want to summarize. So Sam talked about the different kinds of translations and what kind of modalities would be useful. Thomas brought up the concept of middleware, which I think is really important. And then Nimesha mentioned how I think the contextual aspect is quite important as well, because it may be literally that I'm in a situation and I'm using visual augmented reality, for instance, but I need to switch to another modality quickly, because otherwise I may drive off a cliff or something. So I think it's not just that you kind of settle on one modality and stick with that, but I think we actually need to be able to both switch between output modalities and also even use several simultaneously. There may be situations where you need to actually have a reinforced set of outputs at the same time.
I think in any case, we can all agree that we shouldn't be using any of this technology near cliffs.
We may not have a choice. If you've ever been driving in California, that's not much of a choice there.
Or we can use these kind of technologies to train the people if they have like phobia for the clips and stuff.
Yeah.
Right. Thank you again. So let me remove the panes.
And I notice now that we have a chat open, right? So now we can.
Not for everyone. Not for everyone.
We have for everyone. Okay.
Yeah, we have to restart the session for that feature to be enabled. We'll do it once the session is done.
I got it. Yeah. Okay. Thank you, everybody. Great questions. Glad to be in the workshop.
So the second talk is the value of sound within multisensory approach to AR in the arts, by San Bilbo, Chris Kiefer, and Cecily Chevalier. Apologies if I mispronounce the names. From Experimental Music Technologies Lab, School of Media, Arts and Humanities, from University of Sussex. Floor is yours.
Hi. I'm just going to be sharing the screen, but all three of us are in different places in the UK, so we'll be speaking out of different videos here. So if you can't see the person who's speaking, you can maybe change to the gallery view whilst I'm sharing my screen, just to let everyone know.
I will pin all three of you.
Thank you so much. Can everyone see the presentation? Cool. Hello, everybody. We're joining you, as I said, from various places in the UK, but we're all members, as Thilina said, from the Experimental Music Technologies Lab at the University of Sussex. My name is Sam Bilbo. I'm a second year PhD student in music technology, and I'm joined by two of my PhD supervisors today, Dr. Chris Kiefer and Dr. Cecile Chevalier. So together, our creative practice and my PhD work in particular focuses on artistic uses such as sound art and immersive installations of multisensory AR technologies within the field of music technology and digital humanities. And in our own research, we have, as I'm sure many of the people here have experienced, the visual bias that AR technologies has inherent in it. And as researchers interested in sound-driven interactive experiences and music technology in general, this has produced quite a high barrier to entry when trying to use AR in our own work. If our bodies are inherently multisensory, as I think everyone here can agree, and the goal of AR is to some extent attempt to modulate our perception of reality, doesn't it make sense that it would do this via multiple sensory pathways? And so in our own work, accessing AR has meant producing DIY or do-it-yourself audio systems to address the visual bias present in consumer AR technologies. So after introducing a shared definition of AR that makes way for this, today we're going to be introducing you to two sound-driven multisensory AR artworks. So Azuma's original 1997 definition of AR, for those that don't know or can't remember, is a system that combines real and virtual, is interactive in real time, and is registered in 3D. The definition of AR that we subscribe to builds on Azuma's definition. In this paper pictured on the right, written by my PhD supervisors, it is defined real-time computationally mediated perception. And by specifying that it's the perception of a participant that is being mediated, it draws focus away from the AR system, which has, over the last 20 years, I think we can all agree, has evolved into typically a visual overlay device, either through head-mounted display or smartphone. And by doing this, the definition emphasizes A, the multisensory nature that experiences in AR must embody, and B, the capability to mediate in multiple ways, for example, by diminishing or extending, not just augmenting, the perception of participants. So I'm going to hand over to Cecile now, and Cecile and Chris are going to be introducing their artwork, Listening Mirrors.
Thank you, Sam, and thank you for having us for this. So can you all hear me? Yes, brilliant.
Yes.
Okay, so Listening Mirrors is a sound art installation, an evolving instrument that wraps and blurs the boundaries between real and imagined reality. And in the previous talks, we talked about memory, and actually imagination was very much part of the construction of augmented reality. It promotes shared modes of musical expression for musician and non-musician alike. There are currently 2 iterations of Listening Mirrors. Both are composed of a parabolic acoustic mirror built from aluminum sheets, metal sheets, piano wires, and 3D printed joints, and all is brought under tension with double bass strings, bending each piano wires and aluminum sheets to form its parabolic shape. While the first iteration includes an open framework, a libPD, and an augmented sound system, the second was custom made. Chris will expand on this in a few minutes. We are currently working on a third iteration, including a new design for its wearable. Could I have the next slides, please, Sam? Thank you. In the early stage of Listening Mirrors, we thought key to scope some expertise in augmented reality, technologization, and cultural transformation with a 2-day forum for augmented reality and immersive instruments. A forum that brought together Sussex Cross School faculty, art organization, artists, creative industry expertise on augmented reality, technologization, and, as I say, cultural transformation. The network event was designed to explore new forms of creation, experience, and digital culture through tools and instrument making, from Microsoft HoloLens, Pokemon Go, to zspace.com, etc. That had been emerging in area at the time, such as our education systems, entertainment, and cultural memory. We're talking about 2018, just in case you wondered when, whilst achieving independence from existing distribution structure and bringing together transdisciplinary discussion on condition of seeing and listening. The next slide, please. Thanks. So the outcome of the forum was very much, or could have been very much summarized in 2 dominant and recurring points, which Sam raised some already, which is the main one, which was the visual bias, how augmented reality was very much understood within that structure, and a need to clarify a position AR, which Sam's already discussed, in a way that we position AR in our work. So it became key to ask and research the questions that you can see. What does AR mean as a medium for expression in computational arts? How does AR enable artists to create new experiences by directly intervening in multisensory perception? How does audio AR transform the way in which we can express ourselves by changing the relationship of our sensing bodies and the world? And how can design effective collective shared experience in AR? How can we design? And here I would add as well, just before, because in relation to the previous talks as well, that to me, and I would say us, there's a difference between, as we all understand, there's a difference, obviously, between augmentation and prosthesis. And I think when we seem to flip from one to the other, but I think it's quite important to differentiate when we are doing augmentation as opposed to prosthesis. I'm not saying though that AR can't be used for prosthesis, but I think there's a need to clarify that. Yes, our approach to material exploration and design and physical and computational fabrication was experimental, conceptual, and DIY, very much based in the arts and programming, which also meant exhibiting listening mirror was an essential part of a method to design prototypes in real environment. This included the Thought Process Sound Art Festival, where Listening Mirror was played by the public for 8 continuous hours, with not by the same person, with a constant flow of 3 to 15 people at a time. The video could be played, and it'll last about a minute, just over a minute. Thank you. What became clear in designing an instrument with multiple sound worlds as input and output as a shared collective augmented reality experience was that it was complex. Complex in its flow design, sound aesthetics, and audience management with the wearable, as you constantly put new gear on and off. But it was also clear that it enabled new form of listening and performing as a collective shared experience. Chris?
Thanks, Cecile. Can you hear me okay?
Yeah.
Yeah, great. So what I'm going to do is just try and explain a bit what was going on in that video from the perspective of the participants. And usually one of our biggest challenges in this work has been trying to communicate how the experience is without, because it's quite a complex experience, I guess. And if you're there, it makes sense. But showing it through videos doesn't always convey what's going on. So I'll try and talk you through that a bit. So what happens when you walk into the room, you have a headset on, you have bone conduction headphones, which let you overlay digitally created sounds over your natural hearing. So we get augmented reality sounds through this method. And we have a wearable that you wear, which has a couple of microphones in it. And what's happening is the microphones are picking up the sound in the room. They're processing the sound in the room, and so kind of representing the room in a different way to you. And we do some processing with a lot of compression and filtering And what that does is kind of highlight the sounds of your own body, so you can really vividly hear your breathing and vividly hear the sounds in the room. And we use reverbs to alter the sense of space in the room as well. So it's a kind of live reprocessing of the acoustic environment. As part of the collective experience, then these sound streams get shared with other people who've got the wearable headsets on as well. So you kind of have this shared audio experience. And then coupled with this, we have the mirror, which you saw in the video, which sound is projected through, and also it picks up sounds. So we've got kind of a haptic experience going on there as well. So it's a kind of quite a complex mess, and the idea is that we try and change the way that our participants are engaging with the environment through augmented reality, and then the environment becomes playful and something to explore and something to have a shared experience through. Sam, could we go to the next slide? Thanks. This is a kind of overview of what it looks like top down. So we've got this mirror, we've got some speakers to project sound additionally to the mirror, and then the participants will all wear these headsets, and we can have several participants at once sharing this experience. Can we go to the next slide? Thank you. Yeah, we use bone conductors. So this is a really nice way of doing sound augmented reality, because the bone conductors and headphones let you use your natural hearing, but then we can layer extra sounds on top, and the bone conduction technology works through vibration, so you can kind of hear your kind of skull being vibrated, basically. Let's move on to the next slide. And this is our wearable that we've developed. It started life as a iOS app, but for various reasons we find that quite limiting, being part of that ecosystem for our particular purposes. So we decided to customize, and we rebuilt it using a little ESP32 board. And what this does, we've got a server with Wi-Fi, and these devices, they record the sounds from your personal acoustic area, and then they send the sound, they stream the sound to a server which processes the sound and sends the sound back to your headphones. So they're kind of almost like a dumb terminal, but for sound. Could we move on to the next one? Thanks. So reflecting on what we've been doing, really, it's quite a challenging area to work in, trying to create experiences in this way. We found one of the biggest challenges is composing the experience and getting the balance of virtual and real experience, and so they're coherent and continuous rather than overriding each other. We've also sometimes found it quite challenging to make this properly immersive. So the bone conductor headphones are really good, but under certain frequencies, like if you put too much bass through them, they start tickling, and then you suddenly realize that you're wearing headphones, and it kind of ruins the immersive effect. So we're experimenting with ways of trying to keep the spell, if you like. We're really interested in cross-perceptual, cross-modal integration, and the idea possibly that we can use sound to change our other senses. So for example, if I'm rubbing my finger over a surface, that makes a sound, but can I process that sound to change the texture of the surface? So can I override my other senses with sound? I think I'm going to hand back to Sam now.
Thanks. Yeah, I'm going to be, if you can hear me, is that working? Yeah. I'm going to be talking about some artistic experiences that I've been developing, but more in generally a framework that I've been developing. So yeah, as I mentioned in our introduction, we find that current consumer AR technology is limited when it comes to these kind of fine-grained audio control and playback experiences, and that taking an open source and do-it-yourself approach kind of fixes this limitation by putting the means of production in the hands of artists and developers rather than in large corporations that are currently creating these AR headsets for large amounts of money that I'm sure that everyone knows how much these things cost. So yeah, Polaris is something I'm going to be talking today. It's a framework for creating and developing open source multisensory AR musical experiences and instruments. And open research questions on this project include: what's the potential future for AR digital music instruments? Can AR's materiality be exploited to offer rich and embodied experiences of self, others, and environments? And what aesthetic experiences from perceptual modulation and sensory illusion are available through AR? And so this framework includes both hardware and software components, and it results in real-time interactive instruments that feature audiovisual 3D alignment and expressive gestural capabilities. So I'm going to first talk about the hardware portion. So it's a combination of an AR headset and bone conduction headphones that Cecile and Chris talked about earlier. There's a pair of them here, quite lightweight and wireless. So the headset to start off with is an open source Project Northstar AR headset, which is completely 3D printable and whose PCBs and sensors come to a total cost of about 500 to 600 euros. But despite this low cost, the headset has accurate 6 degrees of freedom head tracking and industry-leading hand tracking, as well as the widest field of view of any AR headset. And due to the configuration of the headgear, it's also compatible with bone conduction headphones, as you can see in this picture. I'm wearing both the headphones and also the headset. It's also got a large community of about 2,000 users on a public Discord server who are extremely helpful in getting everything working. So that's the hardware portion of this framework. Moving on to the software, I'm going to split the stack into visual and audio parts in order to just clarify their features real quick. So the visuals are taken care of by Unity, which a lot of people might know of, and Project Esky. So Unity, for those who don't know, is a free 3D software with a very capable physics engine and parametric audio and visual properties. Project Esky is an open source renderer for the Northstar headset, which allows the head and hand tracking to update the position of items in Unity in real time and assigns them all as collidable objects, which is great for physics interactions. So to give a brief interaction example, I outstretch my hand with the headset on, and my hand joints are instanced in Unity as 3D positional and orientational relative to my headset. And then the items are rendered to the screens inside the headset, and I gain an aligned virtual hand counterpart that can interact with objects in the Unity scene. In addition, Project Esky also opens access to Microsoft Mixed Reality Toolkit and Elite Motion assets, which is really useful for just generating quick UI sliders and buttons that are pre-made and work in AR straight away. So that's sort of like the visual and interactive part. Unfortunately, without a lot of effort developing inefficiently in C# in Unity, is the program language that Unity uses, the native Unity audio is stuck with just being able to play back sound files. And to its credit, the spatialization in Unity is really good. So as I move an object from left to right, I can hear it in my left and right channels. But being stuck with simple sound file playback is fairly limiting to sound artists. So Polaris uses Pure Data, which is a free and open source visual programming language that has been being developed for nearly 25 years now. And as such, Pure Data is widely used in the music technology community because it has extensive real-time synthesis and algorithmic audio capabilities. So for example, here is a Pure Data patch. When you click on that button, it randomly changes the frequency of a sine wave oscillator. Maybe interesting for making like little bleeps and bloops, but patches can become a lot more complex with the ability to compose generative and even probabilistic computer music that can react to light sensors, microphone input, and even biofeedback. So in order to use Pure Data and Unity together, Polaris uses the open source libpd integration wrapper, which is really helpful because it can mean that you can write a pure data patch that makes music or audio, and it can be instanced in Unity across any number of game objects that you want that are all spatialized in 3D, and that all come back into the bone conduction headphones. So the experiences that arise from this, there's an immense amount of possibility in the kind of experiences that you can create from the combination of projects in this framework. So far, I've only kind of made basic synthesizers that react to UI sliders and hand movements, but I think that from the outset, the framework has shown like a great amount of potential for creating multisensory AR instruments and experiences. So I'm just going to show 3 really short demos of some sound, some instruments that I've made. They might be quite quiet, so you might need to turn up your sound. And we can leave this one here and move over. You should be able to hear it in the left a bit more because it's on that side of me. So I hope they all came through. Oops. So in the next couple months, I'm going to be conducting some in-person user studies for these instruments, or the next instruments that come along that might be slightly more interesting and have more visual components. But I'm interested in using some enactivist principles as design guidelines, and you can read more about this in our position paper, which is kind of the main topic. Today we've been introducing our context for using multisensory AR. But also I'm interested in creating an open source wiki for guidelines on how to make musical instruments in AR and VR. In the long term, I want to investigate the senses such as touch, smell, and taste, which are notoriously more harder to interact with through technology, but we're definitely getting there, and there's some interesting technology available now for those sorts of experiences. And lastly, to integrate sort of multiple participants all wearing different headsets and being able to interact with each other. So thank you so much to the workshop organisers for hosting us today at this workshop, and yeah, we welcome any questions that you might have for us.
Okay, we'll open the session with Thomas. Thomas has is it a question now, right?
No, we're just uploading here from Italy. So thank you.
Yes. So any questions? We are having a lot of uploads.
Maybe I can go ahead with the, I don't know whether it's a question or a comment, or just try to think out loud. Sam and Cecilia and Chris, I think that it is great work. I think I was wondering about 2 things. The first one is when you are showing that video with the violin, is it a bow, right? We call it the bow. So I was thinking, how can we represent, or how can we come up with a framework where we can use AR technology to sort of like during like teaching how to use these instruments, like some of these subtle variations, for example, especially when you are playing like a violin, how do you can teach them how to play a note, for example, but you will never sort of understand how subtle you have to change the bow and the finger movements and stuff like that. So are there any like AR work is being conducted on those aspects, like the teaching instrument as well as like the fine tuning those playing conditions? I was just wondering about that. And the other one is when Sam is explaining about his future work, probably integrating the smell, taste, and other sensations. I was interested in, I saw some work which people have conducted, like the studying the influence of different audio frequencies on the olfactory perception or the smell perception. I don't really know the opposite of that. Like if you are playing on like an orchestra or like a musical session using smells, can we sort of enhance the experience of the users? Or can we decrease some aspects of that orchestra and emphasize some other aspects of the music? So I was just wondering about those notes and points.
Chris, do you want to answer the bow question?
Yeah, so I believe there was a project called iMaestro.
Okay.
Might have been 5 or 10 years ago by Kian Nung from Leeds University, which did a kind of video tracking of people playing the violin. And I don't know how explicitly AR it was, but it kind of did some like visual overlays to help people improve their bowing skills and so forth.
Yeah.
I would just add one point on this, which is not to do with education, but in a way is also having participants or an audience coming to a piece of work that looks quite alien to what they know, and how to engage, how to let them engage with it from their own willingness, rather than we're going to do this to you. So
yeah.
And the bow was very much part of giving them a tool that they knew, understood, so they can actually engage with this piece. And art was also is a problem in now, where we in the arts, people are not meant. I mean, of course there's plenty of work now that do, but it's still conditioning in the audience to not touch art. So, and especially when it looks sharp. So, we also have to overcome that, and the bow help. That's all I would say.
Yeah, I agree.
I believe that this teaching musical instruments has always been one of these core use cases for augmented reality in music, and one that it is still kind of rooted in this visual dominant overlay of notes coming down, sort of like Guitar Hero, and then you play on the piano.
Yeah.
Similar, and we've witnessed that use case for nearly 15 years now, and it's still coming up and again and again and again. It does exist in the context of musical education, but institutionally I don't think it's there yet. There's a lot in music that you can't teach, like fine-grained expression and gestural expression in musical performance, that I don't know if you could get cameras that were accurate enough to be able to teach you that kind of stuff, and whether or not as artists we want that kind of thing to come from technology or not. But it's a great conversational point. To answer your question about smell, specifically with integrating smell into instruments from this Polaris framework, I was thinking more about more abstractly in an installation context where you have multiple people with audiovisual headsets on, the ability to kind of free roam between zones of the installation that had, and I'm thinking out loud now, but just smell pumps with the different smell intensities in different areas that affected the audiovisual experience. There's some great research that you might be aware of out of the Pedro Lopez's lab, with similar to your own work in temperature in VR, using smell pumps to introduce capsaicin and eucalyptus oil into the nose in order to simulate cool and warm environments, and and I believe it was an open source endeavor, and so it would be not too difficult to integrate a smell pump into an AR headset. It would probably just have to be underneath it, so it wasn't in front of the user's view, but I could go either direction in a sort of room scale or on a personal scale. But yeah, I would probably go through the same method of thinking for haptics, rather than obscuring the user's sense of their own hand by putting a glove on them. Interact with tangible objects in their environment and augment those objects rather than the hands of users.
Or if they are like sitting on a chair, probably the chair can be vibrated or.
Yeah. Taste is more elusive to me. I'm not sure how I would approach that. It would probably get quite messy, the electronics, but something I'm definitely interested in. Thank you so much for your question. Very thought-provoking.
That's great. Thank you.
All right. Any other questions?
Yeah, Thilina, I would like to give, I mean, it's not a question actually, because Nimesh has already covered part of that question I wanted to ask. Yeah, Sam, Cecily, and Chris, I think this is a great work, and particularly I was interested about the cross-modal studies that you have mentioned, because I have seen quite a lot of similar cross-modal studies conducted. I mean, not in your field, but quite a lot of cross-modal studies conducted by Professor Charles Spence from Oxford. So, for example, he tried to change the sound of a dining table, surrounding dining table, and then test how you can alter the perceived taste sensations. So like that, and I think that is a very exciting and interesting research area. So I mean, I am really excited that after Sam said, like, we want to also explore the touch, taste, and smell. So those modalities, when you conduct cross-modal studies, I think you will find lots of interesting results. So eagerly waiting to read your papers in future. Good luck.
Thank you. And I think there's an interesting connection between what you say, Kasun, and what Thomas mentioned about the brain filling in multisensory percepts. And especially in Charles Spence's work, when he works with isolating the sound of a packet of potato crisps, and that having an impact on the way that you feel when you eat them, and removing the sound, and that aligns with our work as well, because we see augmented reality not just as overlaying visual stimuli, but also being able to take away or affect. And what Thomas said about the brain filling in things, if we come to integrate taste into our artwork, it doesn't necessarily have to involve technology. All you need is someone to be eating something at some point, and maybe the visual or the audio having that cross-modal effect. So like similar to some early work by Narumi in 2011 with the AR headset with the cookie, and it was just a visual overlay on top of the cookie that would make it taste like chocolate or lemons. They're not changing the taste at all. It's not some gustatory overlay. It's smell and vision and audio filling in the gaps, and that makes the barrier to entry in artwork much lower, because the taste technology, I don't know, for me at least, it seems quite far away, but being able to access it through cross-modal perception brings it so much closer.
Thank you.
All right. So thank you for that wonderful presentation. If there's nothing else, let's move to our last talk for the session. Let me unpin all of you. Right, so our last talk for the session would be the use of augmented reality to deliver enhanced user experiences in fashion industry by Chamodi Jayamini, Asangika Sandamini, Tisara Pannala, Prabhash Kumar Singh, Dushani Pereira, and Kasun Karunanayaka from the University of Colombo School of Computing, Sri Lanka. So it's yours, guys.
Hello, everyone.
Yes, you can go ahead.
I think you can see the screen. So first, we are excited to present our position paper on the use of augmented reality to deliver the enhanced user experience in fashion industry. So mainly this presentation is consist about literature background on exploring how to use the augmented reality in fashion industry. So our team has 6 members, including myself, Chamodi Jayamini, Asangika Sandamini, Tisara Pannala, Prabhash Kumar Singh, Dushani Pereira, and Kasun Karunanayaka. We are from University of Colombo School of Computing, and myself and Asangika and Tisara are undergraduate. So when we go introduction about fashion, we know that the fashion is from ancient time to present, the fashions, the patterns, style of clothing are change to change, and the clothing reflects the pursuits of beauty. So the dress has been one of the embodiment of our human civilization, as you see here in this figure, how the evaluation of fashions from 1860 to 2021. So we know from these, we think that we have know that the fashion industry is a vast area that will be consist of production of raw materials, sometimes the production of the goods by designers and retail seller. So when we concern about this fashion industry, as it is become a global economy, but this due to this restricted social life we are facing this during this COVID-19 pandemic, people want to satisfy their fashion needs and want through the online platform. As an example, when we want to try to buy a clothes from online shop, we face many problems as we cannot fit our clothes in virtually. To get a solution to these kinds of problem, augmented reality and machine learning technology comes in drive. So in most of the cases in fashion industry, it acquires solution to these problems through augmented reality. So now let's consider how this augmented reality apply on our fashion industry. So we know that augmented reality in fashion domain, it enhances the consumer's sensory perception by blending the virtual world with real world. So this augmented real technology are trying to enabling the interaction with the virtual garment items to encourage the buying intention. So with this rapid development of this application in augmented reality, most of the researchers are done like technologies like virtual mirrors, virtual 3D images, virtual fashion shows, and custom design system. So we have done a background study about how this augmented reality used in fashion industry and identify key 3 main areas that affected with augmented reality. The 3 areas that affected with augmented reality in fashion industry is fashion design, apparel self-customization, and customer shopping experience. So firstly, we know this fashion in design is, we use this fashion design in augmented reality. By using augmented reality technology, it helps to sometimes enhance our designer skills and knowledge through different augmented reality tools. And in apparel self-customization, we are trying to use this augmented reality technology to help people to customize their clothes according to their preferences, colors. And other than that, nowadays we use applications like virtual mirrors, virtual fashion shows to enhance our customer shopping experience. So now let's see what are the researchers that have done in these key areas. The first key areas affected in augmented reality fashion industry is this fashion design. So in this fashion design, the augmented reality technology is used to, I already tell that it is used for enhance our designer skills and knowledge. So the first research we can find out to identify in the field is body ID system. So it will propose to get a quickly build, refine and test on the body interaction without need to connect to program electronics. So we know that while most of the toolkits, prototyping tools are wearable technologies that will be helpful to facilitate in implementations and look and feel. But this system emphasizes how to interact with garments and response with various actions and context. For this system, it is initially implementation using technologies like Unity, Kinect, and RFID tags technologies. And here you can see in the next slide, as in this figure, how these component stacks like this buttons, new teeth, LED, sound effects get together to form an input or a connectors or output statement. And from these connecting and getting input system, they make a virtual clothing tag. By wearing this virtual clothing tag on a designer and activated this button in front of a mirror, we can render the behaviors of the wearer and see how the behaviors are going. So in this body ID research, we can see the limitation in it cannot explore how the real world materials like light and fabrics are in virtual component environment are used. So other than this research, we have many when we presenting how the designs in education, how fashion design in education, we found out an interesting one. It is this colleagues done this research is under creating a two application, one application for learning design theory education and other one is for learning pattern making fashion design education. So here you can see this in the left side of the picture, they use this application for learning design theories in fashion design education, and from this application they are trying to visualize the 3D models for costume form recognitions and differentiation. So these applications in the right side, it is used for the pattern making education, and from that they are trying to render the 3 models of pattern making process to see by student how the images are rendered to 2D images in the textbooks. When we going through this application, how renderings images to 2D images in textbook, we got another research in the next slide. You can see how to develop an application of for education by developing a textbook's topics by using augmented reality application. In here, they propose a system. They create a 3D model in a symmetrical with asymmetrical element to visualize the 2D image printed in textbook. In here, the researchers are trying to get the QR, and from that QR technology, they are trying to render the 3D models by 2D images. So when we going through these researchers, sometimes the surveys are done by these different researchers. So in the next slide, we can see how this Elfiki and Elbaevi measuring the effectiveness of augmented reality application on fashion design students' education to enhance their skills in functionally, aesthetic or creative fields. So they conducted this survey with 2 groups. For one group, there are 54 fashion design students, and they are trying to get the one group, and they will be trained and hand over with the developed application called Outsuma, that can be downloaded from Google Play Stores, and from that they are learn the fashion design products theories through videos. And other group, they learn the same thing in hard skill. From that, they prove that when we using augmented reality application like this Outsuma tools, the effectiveness of learning and getting high knowledge is more than the hard skills students. So these are some of the researchers used in fashion designs that we have find out. And other than these researchers in fashion design, we have found some researchers on apparel self-customization also. So when we move to next, we know as a world, the fashion industry is mainly consists with the mass customization. So from the retailers, they are trying to cover the needs and wants of people. by giving the mass customization and that. But people in nowadays tend to customize their own fashion products with different colors, styles, patterns, with their cater their preferences. So for these purposes, many researchers done different application with augmented reality technology to enhance this apparel self-customization. One of this is this one. So these two colleagues propose a solution for a cloth with realistic illumination using augmented reality. In this solution, the researchers are trying to aim an image on the user who wear a t-shirt by using marker-based technology and finally virtually try it on. So here in the next slide, you can see how the marker-based technology used in this research. And from that, they are trying to build the real-time environment by applying the correct shadows, illuminations on t-shirt. One of the limitations we think they are only do this research only for light clothes. So if we can produce a method to allow for not a light clothes, we can develop this method. So, and other than this research is only applied for certain garment types only. So in the next slide, you can see another research of developing of this fashion framework that will be for designing customization of footwear for children. Mainly this research is support for 5 design module as colors, textures, embroideries, carving styles and shape. In this research framework, they are trying to help for the customers to virtually try on the footwear on his or footwear. For these approaches, their methodologies, they use technologies like Kinect for capturing the depth of the superimpose, and they use augmented reality toolkit for object detection and Unity 3D for rendering colors and textures. In both the previous research that I told, they are just like a single customization products like footwears and t-shirts. So here nextly you can see research on a full feature clothing customization done by the researchers. They are trying to apply various designs on the full feature cloth and virtually try it on. This research is involves some implementation of a material library for selection of styles, patterns, colors, and fabric for users to choose. And they use mainly the Azure Kinect Multisensory for capturing depth data in human bones and virtually try it on 3D cloth on human body. And other than that, they use OpenGL rendering for render the clothing texture in lighting. So that technology, how they using showing next slide. As in this research, these technologies are using. One of the limitation that we can find out is this method is only for handmade module that require the skilled professional. So these are some of the researchers we find for apparel self-customization. Nextly, we move what are the researchers done in enhancing customer shopping experiences. So that we know that since most of the customers move offline to online shopping, even in the retail industry, most of the retailers have to move with this technology. So the difference between the two medium is the online experience is provide high-end digital content and it increases the demand of the product. So when we providing a product information is more critical in an offline shopping also. So to bridge that gap, Johnson Martin nextly propose a novel augmented reality mobile application that provide a better product information for in-store customers. So in here, the customers do not want to assist the sales assistant for information like size available and colors are available. We can say this is like bringing online to offline. So what they have done is this study is first they conduct a user service study and they gather what kind of product information where they prefer. And from that, they are trying to retrieve parameter sets and they consider when they are shopping. So after that study, they have developed a prototype to scan a 2D pattern on a garment price tag using application and then scan a 2D pattern on a physical mannequin. So it will project this 3D model of a scanned garment on a mannequin and adjust this measurements on a mannequin. So by doing this, user can give an idea about how to fit the garment. In addition to that, they can display information like sizes, colors, origin of like this in the picture. So for the development of application, they mainly use Unity 3D, Game Engine, and Vuforia AI toolkit. Generally, the aim of the research was to investigate how to enhance the in-store customer experience using augmented product information. So another area of using augmented reality to enhance the user experience is retail industry's virtual try-ons. So we know the Magic Mirror. So Magic Mirror is one of the popular virtual try-on solution. So there are several studies conducted providing a virtual try-on experience using larger screen. But the studies change from those because here the researchers have used the IoT smart mirror. As I pointed out, this is an IoT mirror act as a virtual try-on. From that, the augmented reality has been used to recognize the skin color. Other than that, the system recommends clothes according to the skin color of the user. So, and after that, they are trying to add this virtual cloth on the video. So for that, for getting the track of the human skeleton, they use web camera and the TensorFlows. And by using this system like customers, they can get a realistic try before buying them to them. So in the next slide, you can see a research in developing application on fashion show. So another most part of the fashion industry is the fashion show. We know that. So usually this fashion show are professional and accessibility is limited, but recently the fashion shows have incorporated with technologies such as augmented realities and mixed reality with this pandemic situations. These two colleagues present a novel augmented reality to give a augmented reality fashion for apparel show system named Personal Day Life Show. In there, they are trying to generate life size, or I could say a personal 3D human model to generate the 3D apparel modeling of a 2D garment available at the online site. So this system enables to generate this avatar to wear this generated 3D garment and interacted with this physical environment. So user can see how to wear a cloth and how to interact when doing the daily life activities. So augmented reality technologies are used to visualize this supremacist personal avatar in users in real environment. And for the implementation of this prototype, they use augmented reality head-mounted displays and Microsoft HoloLens, and for this real-world measures in the system, and the software that was developed using Unity 3D and MRTK toolkit. So in here, in the next slide, we have added a picture of the initial prototype pipeline, and you can see that in here there's a personal avatar generated by modeling with the face of the user and the body. That means firstly we build the model with the face, and then we build a body, and finally combine those models to get the final avatar of the user. In this research, they use these images like front end and side images, and these images are used to generate this model. So these are some different areas that are used by researchers to enhance the customer shopping experiences. As these resources, we can say that augmented reality technology can be used to narrow the gap between the online and brick and mortar shopping experience. So from the background study, we have found out several use cases of augmented reality that helps to enhance the fashion industry. And as a conclusion, we can say that augmented reality technologies help to use to enhance the fashion industry by introducing different applications like virtual fashion shows, showrooms, fitting rooms, to fill this gap between the fashion industry in this time. So by using this augmented technology in fashion industry, as a designers, customers, retailers, we can get a huge advantages. And as a researchers, if we can find the gap between this industry and introduce the augmented reality technology application to fashion industry, we think it is a good impact to the society. So in this next sliders, you can see some of the references we used in preparing these presentations. And by doing this position paper, we are trying to get a good background study about how the application are used in fashion industry and their limitation. And we try to get try to find a problem, and we can apply for our research in our undergraduate. So that is our end of our presentation. Thank you for your kind attention to us. Thank you so much. If you have a question, you can ask from us about this background study.
Right. Thank you, Jamodi, for this talk. Now the floor is open for the audience to ask questions.
Maybe I can add another point or another direction to this work. Thanks, Jamodi and all, for the nice collection of works. I think a few years ago, I saw sort of like another dimension to this aspect, or this line of works, because right now, most of the work you explain are like looking through a lens and then try to do something with the visuals and in the AR space. I think the one example I show is like they are using shape changing materials so that your wearable or the cloth you have or the garments you are wearing, it can be changed and augmented the shape, the look and feel throughout the day. For example, you can there are some garments, I'm not exactly remember the technology or the how they do that, but they are like shape changing. For the user context they had is like, in the morning you can wear the same dress to the office, and then in the evening if you are going to a party you can change the shape of the dress and go to the party with the party looking dress code. So I think that's again another aspect of the AR work with the fashion industry and garments, and probably you can look into that aspects as well. I just want to highlight that. Thanks for the presentation.
Yes, Lars, if you can go ahead. Lars Erik.
Oh, yeah, thank you for a really nice presentation. I was thinking about the whole concept of multisensory fashion, because what we saw was very much visual based, and fashion is partly visual based, but it's also, there is a lot of other aspects. I happen to be based in a design school, so I see a lot of fashion and material work there. And one of the interesting things is how they use different kinds of materials. It's not just a plain single two-dimensional cloth, but very often the texture, the weight, the all other kinds of aspects that are not just visual. It's not just the color, but the way that you can, even the flexibility of the material and so on. So I was just thinking how far you could take that in a multisensory environment. And even when you see it, even if you only see a piece of clothing, you can still see from the person wearing it if it's heavy, if it's stiff, if it has different qualities, and also the functional, like is it hot, is it cold, so on. So do you have any comments on that? Is there a next step from the visual in multisensory AR for fashion?
Last, I think I will answer that question. Yeah, couple of years ago, we have tried to came up with a jacket with some conductive threads. Using conductive threads, we can do a circuit. So, and then connected into some kind of a small scent diffusers. So we have made a very rough kind of prototype where we can do based on the environment. So we can sense the environment and then diffuse some different types of smells. So that was one part of the part of this project. And then mainly in this these undergraduate students, for their 4th year project, they are working on like how AI can involved in fashion designing. So maybe yeah, maybe Chamodi can explain a little bit more about that.
Yes, we are trying to build a cloth from the generative adversary networks. For that, we are for as an input, we are trying to give the theme, and from the theme, we are trying to build up a cloth from generative adversary network, and we can visualize the output through the augmented reality application. We know that a generative adversary network is a good creation model for creating different garments, different clothes. So we use that technology for creating this fashion clothes. Sangha Tisara, you want to add some things to it?
Yeah, in case that you didn't understand what this theme means, let me just share a image. So our focus on our research, I hope that you can see my screen, right?
Yes, this one.
Yeah, okay. So in here that like in this cloth is made by when we are inputting this bird figure to the GAN model, then it will generate this kind of cloth. So this will take the bird models like texture and color and also the shape of that, and then it will create some kind of this type of dress, and this will be created in 2D. But then it will be we are hoping to use AR in order to like visualize this generated cloth in a human body. That was our now current work going on.
Cool, thank you.
Yeah.
I think that's really interesting, especially the colors as well as the structures. If you can learn from the nature, you should look into the work done by Neri Oxman from MIT Media Lab. She's also using a lot of like bee structures and similar structures inspired from the nature and using into the apparels and other fields. So very, very interesting.
Yeah, thank you, Nimesha, for the suggestion. And actually, that is one thing that we are looking for. Like, for example, you take a photo of a beach and then you add it into the general adversarial network model, and then that can come up with a new design. So based on a theme, and we are also thinking of a model where you can draw a simple sketch. So you can draw a simple sketch and then you can input some kind of theme via image, and then the AI model can build some kind of design for you, and then you can test that particular garment fitted into a AR model, like 3D model, or you can fit it into a real human in the real time, and then you can check how it looks like.
All right. So, any other questions? Seems that's the end of the questions, and which leads to the conclusion of our session as well. It was kind of a lengthy session. However, I believe it was fruitful. So thank you very much for all the authors, presenters, for your contributions, and for the attendees, for the attendance. If this was a physical sort of a conference, we might be having a round of applause. Right now, you do the reactions. And Kasun, next is
yeah, Thilina, and I think Professor Dawal is here, right?
Yep, my supervisor is here. Dawal is the other organizing committee member.
Yeah, and I think we can take a 15 minutes break and come back again for the second paper session.
Right.
One thing from from Italy here. I mean, we are
Yes,
actually 2 or 3 participants here who are physically in Italy, and we need to kind of stick to the lunch schedule.
Yeah, sure.
Okay.
When is that, Thomas? I mean, how long?
I'm not so sure, but I presume that the schedule that
maybe
you
it is right now, right?
It's right
Yeah.
now.
Yeah, it's right now.
It's okay. So 1 to 2 o'clock.
No, 12:30 to 1:30.
Okay.
Based on Italy time.
Okay, maybe can we just check with the organizers here?
Yes, sure.
It's one of those times, and I will get back to you so we can kind of. But it's not a problem. So
Kasun, we can have the 1 hour break now.
Yeah.
And then,
I think we can come after, right? Prof. Anton, what do you think?
Agrees.
okay, so yeah, so 1 hour break works fine for the participants in Italy at least.
Yeah, sure. Yeah, thank you, Thomas. So we will have our 1 hour lunch break now, and then come again, meet again around 1:30 p.m. Italy time. Thank you.
Yeah.